Next, let's have a look at the programming problems. Difficulty with the drive operation can be a result of improper programming of the drive parameters. 3 areas where programming errors may affect the drive and motor operation are motor settings, references and limits, and input-output configuration. The drives must be set up correctly for the motors connected to it. Parameters 1 to 20 to 1 to 25 must have the motor nameplate entered into the drive. This enables the drive processor to match the drive to the power characteristics of the motor. The most common results of inaccurate motor data is the motor drawing higher than normal amount of currents to perform the task expected of it. In such a case, setting the correct values to the parameters and performing the automatic motor adaptation AMA will solve the problem. The AMA is run by activating parameter 1 to 29. It is always recommended to run the AMA. Any references or limits set incorrectly will result in less than acceptable drive performance. Next, let's have a look at the motor load problems. Problem with the motor wiring, or mechanical load on the motor, can develop in a number of ways. The motor, or motor wiring, can develop a phase-to-phase, or phase-to-ground short, resulting in alarm indication, and a trip of the unit. A motor, with the unbalanced, or non-symmetrical impedances, on all the 3 phases, can result in uneven, or rough operation, or unbalanced output current. To determine whether the problem is internal or external to the drive, disconnect the motor from the drive output terminals. Perform the dynamic output test procedure on all 3 phases with an analog voltmeter. If the 3 voltage measurements are balanced, the drive is functioning correctly. The problem is therefore external to the drive. If the voltage measurements are not balanced, the drive is malfunctioning. This typically means that one or more output, IGBT, is not switching on and off correctly. Perform the IGBT gate signal test. Now we shall see the various faults in the drive. The most common faults in the drive are overtemperature fault, current sensor fault. In the event that an overtemperature indication is displayed, you have to determine whether this condition actually exists within the drive, or whether the thermal sensor is defective. This can be easily detected by feeling the outside of the unit if the overtemperature condition is still present. If the drive is stopped and cooled, the LCP reading shall show the ambient temperature. If not, the temperature sensor, or temperature measurement circuit, is defect. For enclosure drives, if the drive is stopped and cooled, the LCP reading shall show the ambient temperature. If not, the temperature sensor must be checked. This can be done with the use of an ohm meter. The resistance at 25 degrees Celsius shall be 10 kilo ohms. The other fault in the drive is the current sensor fault. When a current sensor fails, it is indicated sometimes by an earth fault alarm that cannot be reset, even with the motor leads disconnected. The simplest method of determining whether a current sensor is defective is to disconnect the motor from the drive, then observe the current in the display of the drive. With the motor disconnected, current should be 0. A drive with a defective current sensor will indicate 0.00 amps current flow. In the situation of a defect current transducer, the LCP will show either an earth fault or a current of a given level when the hand-on button on the LCP is activated. Electromagnetic compliance, or EMC, are the voltage and current, which are not sinusoidal, but pulsating. Electromagnetic compatibility, EMC, Concerns for typical commercial and industrial equipment. Let's now see the effects and sources of EMI, electromagnetic interference. EMI-related disturbances to drive operation are uncommon, but the following detrimental EMI effects may be seen. Motor speed fluctuations, serial communication transmission errors, drive CPU exception faults, unexplained drive trips. Detrimental effects to these systems may include the following: pressure, flow, temperature signal, transmitter signal distortion, or aberrant behavior, radio and TV interference, telephone interference, computer network data loss, digital control system faults. Modern adjustable frequency drives utilize insulated gate bipolar transistors, IGBTs, to provide an efficient and cost-effective means to create the pulse width modulated PWM output waveform necessary for accurate motor control. These devices rapidly switch the fixed DC bus voltage, creating a variable frequency, variable voltage PWM waveform. This high rate of voltage change, dV by dt, is the primary source of the drive-generated EMI. This ends our stay in motor and drives application. With this we have come to the end of this module. I hope you would have got a clearer understanding on the drives and motor application like torque limit, current limit, and unstable motor operation. The various trips in the drive. Common drives and motor problems. Faults in drives electromagnetic compatibility.